Section 8.6, Solving Radical Equations. So now we're going to get into solving. To solve radical equations, the first thing you want to do is isolate the radical, which means get it by itself. If two radicals exist, then get each one on opposite sides of the equal sign. Step 2, raise both sides to a power that equals the index. Why do you want to do that? Because that's going to cancel out your radical. Step 3, solve the resulting equation. It will either be linear or it will be quadratic. So at that point you should be able to solve that equation. Step 4, check your answer or answers to see if there are any extraneous solutions. What does it mean to be an extraneous solution? That means when you plug the answer back in, it doesn't work. Because what's happening is you're changing a radical equation into either a linear or quadratic. And for linear and quadratics, all real numbers work. But not everything works for a radical. So number 1, the square root of y equaling 5. We want to solve and then identify any extraneous solutions. Let's follow the steps. First step is to isolate. It's already by itself. Second step, raise both sides to a power that equals the index. Well, what is my index? With the square root, the index is a 2. So I need to raise both sides to the square power. So when I take a square root of a square, it just cancels out and I get y. And 5 squared is 25. When I plug 25 back in, the square root of 25 is 5. So it does check out. Looking at number 2, we have one radical, it's isolated, so we'll raise both sides to a power that equals the index. It's a square root, so again I'll raise it to the square power. So raising both sides to the square power, the left side, the square and the square root cancel out, and negative 2 squared is a positive 4. But when I check that, meaning I plug back into the original, I'm saying that the square root of 4 equals negative 2. That is not true, because 2 does not equal negative 2. So x equaling 4 is considered extraneous. Therefore, my final answer is no solution. So make sure you check your answers. Number 3, we have the cubed root of m equaling 4. The radical is isolated, so now we need to raise both sides to a power that equals the index. Since it's a cubed root, I need to raise everything to the cubed power. So the cube and the cube root cancel each other out, so I get m, and 4 cubed is 64. Checking that answer, the cube root of 64 is 4, so it does check out. Number 4, the square root of 3x plus 1 equaling 4. The radical is isolated, so the next step is to raise both sides to a power that equals the index. The index is a 2, so I'll need to raise both sides to the square power. What happens when you raise a square root to a square power? They cancel out, so I just get 3x plus 1. And 4 squared is 16. This is a linear equation, so I'll subtract 1 on both sides, so I end up with 3x equaling 15. And then I'll divide both sides by 3, so x is going to equal 5. I do want to make sure I check that answer, so plugging it back into the original, I'll do the check stage right here. I'll have the square root of 3 times 5 plus 1 underneath the square root is supposed to be 4. Does that work? Well, 3 times 5 is 15, 15 plus 1 is 16, and the square root of 16 is 4, so it does check out. Number 5, the square root of 6x plus 1 equaling negative 5. So what do we need to do? Isolate. It's already isolated, so we'll raise both sides to a power that equals the index. The index is a 2, so I'll raise both sides to the square power. When I do so, on the left hand side, the square and the square root just cancel each other out, and negative 5 squared is positive 25. So I'll need to solve this linear equation, so I'll subtract 1 on both sides, so 6x equals 24, divide by 6 on both sides, so x is going to equal 4. However, when we check it, plugging it back into the original, I get the square root of 6 times 4 plus 1 is supposed to equal negative 5. And that doesn't work out because 6 times 4 is 24, 24 plus 1 is 25, and the square root of 25 is not negative 5. So x equaling 4 is considered extraneous. And again, my final answer would be there's no real solution. Number 6, square root of 2x minus 1. and then outside the square root plus 4 equaling 9. First thing we need to do is isolate. So I need to subtract 4 on both sides. Make sure you don't forget that first step, which is to isolate. So 2x minus 1 is now going to equal 5. So the square root of 2x minus 1, we have an index of a 2, so we'll raise both sides to the square power. The square and the square root cancel each other out, so I get 2x minus 1, and 5 squared is 25. I'll then add over the 1, so 2x is going to equal 26. Divide by 2, so x is going to equal 13. When I check that one, it does check out, so I'll leave the check stage for you. Number 7, cubed root of 2a plus 7 equaling negative 2. So again, we have a cubed root. It is isolated, so we'll raise both sides to a power that equals the index. So the left side will be raised to the cubed power, and the right side will be raised to the cubed power. The cube and the cube root cancel each other out, and negative 2 cubed is negative 8, because it's negative 2 times negative 2 times negative 2. Subtracting over the 7, we get 2a equaling a negative 15, so a is going to equal a negative 15 over 2. So we do need to check that answer. Yes, we should be able to check fractions, so let's do the check stage of this one. So I'll check it right here. We get the cubed root of, and then 2 times negative 15 over 2, close the parentheses, plus 7 is supposed to equal negative 2. So let's see if it works out. The 2's can cancel, so we end up with the cubed root of negative 15 plus 7. Well, negative 15 plus 7 is negative 8, so we get the cubed root of negative 8, and the cubed root of negative 8 is negative 2. So it does check. Number 8. We have the square root of a plus 10 equaling a minus 2. So we have a square root. We need to raise both sides to a power that equals the index. And the index is a 2, so we'll raise the left side to the square power, and we'll raise the right side to the square power. The left side is nice because the square and the square root just cancel out. But be careful on the right side. On the right side, we have to write that thing twice and FOIL it out. So we'll write it twice, a minus 2 times a minus 2. So left side stays the same. When we multiply a times a, we get a squared. Outer gives me a negative 2a, inner gives me a negative 2a, and last gives me a plus 4. This equation is quadratic because of the a squared, and since a squared is already positive, I'm going to take everything over to the right hand side. So I'm going to subtract a and put all those like terms together, and I'll subtract 10 and put those like terms together. So I get 0 equaling a squared. Negative 2a minus a is a negative 5a, so minus 5a, and positive 4 minus 10 is a negative 6. So I set it equal to 0, so I can now factor. A squared minus 5a minus 6 does factor into a minus 6 times a plus 1. We can't use the 3 and the 2 because the signs would not work out right. Setting each one equal to 0, I end up with a equaling 6 and a equaling negative 1. I'm going to let you check those answers. Once you do so, you will see that the negative 1 does not work. So a equaling negative 1 is considered to be extraneous. We still do have an answer of a equaling 6, so we'll keep a equaling 6. Number 9, we have the fourth root of 6x plus 7 equaling the fourth root of x plus 2. The index is a 4. We have two radicals, but they are on opposite sides of the equal sign, so we need to raise both sides to a power that equals the index. Since the index is a 4, I'll raise both sides to the fourth power. So the fourth power and the fourth root cancel each other out, so I'm just left with 6x plus 7 equaling x plus 2. This is back to a linear equation, so I'll take x's to the left-hand side and I'll take numbers to the right. When I subtract 6x minus x, I get 5x, equaling 2 minus 7 is negative 5. Divide both sides by 5, and I end up with x equaling negative 1. It does check, and I'll let you check that one on your own. Number 10, we have t plus 7 equals the square root of 2t plus 13. It is isolated because the square root is by itself. If you don't like the t plus 7 on the left-hand side, you could flip it over to the right because equality is commutative. But I'm going to go ahead and leave it as is, and so what I'll do is I'll raise both sides to a power that equals the index. My index is a 2, so I'll raise both sides to the square power. Just like on that previous problem number 8, t plus 7 means we have to write it twice and FOIL it out. And on the right-hand side, the square and the square root just cancel each other out. So t times t is t squared. Outer would give me a 7t. Inner would also give me a 7t. And last would give me a 49. And I still have 2t plus 13. Because it's quadratic with that square, t squared, I'm going to bring everything over and make it equal to 0. So I'll subtract the 2t and I'll subtract the 13. So I end up with t squared. And we have a 7t plus 7t minus 2t is going to give me a 12t. And 49 minus 13 is a 36, so plus 36 equaling 0. It is factorable. Factors of 36 add up to 12 are 6 and 6. So I get t plus 6 and t plus 6 equaling 0. So therefore we only get one answer out of that, t equaling negative 6. In college algebra, we'll talk more about what happens at that point. Checking that answer, it does check, so we're okay keeping that as our only solution. Now number 11 and 12 are going to be a little bit longer. And the reason why is what happens when we square both sides, because the index is a 2, our radicals will not disappear the first time. So we're actually going to have to square both sides twice. So just know these are a little bit longer problems than the previous ones. So number 11, the square root of x plus 3 equals the square root of x, and then outside the radical, minus 3. We can't really isolate the radicals in general because the minus 3 is either going to be on the right-hand side. If we add it over, it's going to be on the left-hand side. So either way, the minus 3 is going to be with one of those radicals. So I'll leave it with the right-hand side. So we need to raise both sides to a power that equals the index. Well, the index is a 2, so I'll raise both sides to the square power. Well, the left-hand side is still nice because the square and the square root just cancel each other out. But the right side is not so nice because it wasn't all underneath the square root, which means I need to write it twice and FOIL it out. So x plus 3 is going to be on the left-hand side. Let's start distributing. Square root of x times the square root of x is the square root of x squared. Outer gives me a minus 3 square root of x. Inner gives me a minus 3 square root of x. And last gives me a plus 9. The middle terms do not cancel each other out. They actually get combined. The first square root of x squared just turns out to be x. Negative 3 square root of x and negative 3 square root of x gives me negative 6 square root of x, and I still have plus 9. So what happens is you have to start the process all over again. You have to isolate the square root. Well, to isolate the square root, I need to subtract the x. Well, those disappear, so that's nice. I need to subtract the 9, so I'll end up with a negative 6 equaling a negative 6 square root of x. I almost have it isolated. I still need to get the square root by itself, so I'll divide both sides by 6. When I do so, I end up with 1 equaling the square root of x. Now that I have it isolated, I'll square both sides. And when I raise both sides to a power that equals the index, I get x equaling 1. When I check x equaling 1 back into the original, let's do so. I'll do the check stage right here. I end up with the square root of 1 plus 3 is supposed to equal the square root of 1 minus 3. Well, 1 plus 3 is 4, and the square root of 4 is 2. Square root of 1 is 1, and 1 minus 3 is negative 2. So it did not work out. X equaling 1 is considered extraneous, so we have no solution. So out of all that work, we end up with a no solution. Doesn't always work that way, but in this one it did. So number 12, the square root of x plus 4 equaling 2 minus the square root of 2x. Again, we're going to raise both sides to a power that equals the index. We really can't isolate either of the radicals because no matter what, the 2 is going to be on one of those sides. So we're going to raise both sides to the square power because my index is a 2. The left-hand side is nice because the square and the square root just cancel each other out. But on the right-hand side, because it's not all underneath the square root, we're going to have to write this thing twice, the binomial, and FOIL it out. So x plus 4 will stay as x plus 4. On the right hand side, 2 times 2 is 4. Outer is going to give me a negative 2 square root of 2x. Inner will give me a negative 2 square root of 2x. And last, negative times a negative is a positive. Underneath the square root, 2 times 2 is 4, and x times x is x squared. So let's go ahead and simplify some of these terms. The x plus 4 will stay as is. We have the 4. Negative 2 square root of 2x minus 2 square root of 2x is negative 4 square root of 2x. We just add the numbers in front. Plus the square root of 4x squared. Well, the square root of 4 is 2, and the square root of x squared is just x. So now that our radical did not completely disappear, we'll need to isolate the radical again. So I'll subtract the 4 over to the left-hand side, subtract the 2x over to the left-hand side. So right now I have x minus 2x is negative x. The 4's cancel each other out, and it's going to equal negative 4 square root of 2x. In the previous problem, I went ahead and divided by negative 4. But if I try to divide by negative 4 right now, I'm going to create a fraction. So I'm actually not going to divide. I'm going to go ahead and raise both sides to a power that equals the index. The index is still a 2, so I'll raise both sides to the square power. When I do so, negative x quantity squared is just x squared. And on the right hand side, I'll square the negative 4, so I'll get 16. And the square root of 2x squared is just 2x, because the square and the square root cancel each other out. So I'm left with x squared equaling 32x. Since this is a quadratic equation, I'll subtract over the 32. So I get x squared minus 32x equaling 0. I'll then need to factor, so I'll pull out an x, and I'm left with x minus 32 equaling 0. So I do need to set each of those factors equal to 0. So either x is going to equal 0 or x is going to equal 32. I have both answers, and I do need to check both of them. Once you check both of them, you'll see that x equaling 32 does not work, but x equaling 0 does. So our answer for that one is x equaling 0.